Bismillahirrahmanirrahim. This video is from Electronic Devices and Circuits book by Mr. Bolstead. And here we'll be solving in chapter question 2.22. And this is on the request of a student. So this is the question. Assuming an ideal diode, sketch VI, that is the input voltage, VD, diode voltage, and ID, the current through the diode, for the half-wave rectifier circuit. So this is half-wave rectifier circuit. The input is a sinusoidal waveform with a frequency of 60 Hz. Determine the peak value, not profit, peak value of VI from the given DC value. So using this DC value, which is 2 volt, we have to find the peak value of VI, that is V maximum. So these three things we have to sketch. First of all, VI. Since the signal is sinusoidal and 60 Hz, let's first of all find out what does 60 Hz mean. From 60 Hz, we can find the time period. Time period is 1 over frequency, that is 1 over 60, that is 16.66 milliseconds. This is the time period. This time period is 16.66 milliseconds. The other point, we have to find V maximum for this signal. Okay, so for this half-wave rectifier, as we already discussed, that the DC voltage is given to be 2 volt, and half-wave rectifier output will be something like this. Positive half will pass and the negative half will be clipped. So this is the circuit. This is the output wave shape. And from here we can find the DC voltage. Line is the DC voltage. And the formula for this half-wave rectifier is that VDC is 0.318 V maximum. So using this formula, we'll find V maximum. This is the formula. From here, Vm is VDC over 0.318. VDC is 2 volt from here. So V maximum will be 6.29 volt. So this is our complete input signal. Sketch of the V input. Next, we'll sketch VD, that is the voltage across the diode. And we are just taking one cycle. From here, we'll take the positive half cycle first. Take positive half cycle. That means this is positive, this is negative. Will make the diode forward biased. And because the diode is ideal, so it will be just represented by a short circuit. So this will be the diagram. And we need to sketch VD. You can see there is the total input voltage will appear across this resistance because there is no resistance there. And so VD should be 0. See, this is the output. Total input voltage appearing here. And so no voltage here. VD is 0. So we can plot it like this, that the first half cycle VD will be 0. Now let's go to the negative half cycle. For negative half cycle, negative at the top, positive at the bottom, this makes this diode reverse bias. So it will behave like an open circuit. And now what will be the voltage? See, this voltage is not causing any current to flow in this. That means the output voltage will be 0. That means the input voltage will appear across this gap. Simple circuit can explain it further. Let's say we have 32 volt and we have 3 resistors in this circuit. And if we cut one of it open, then this 32 volt will appear here totally. And similarly, if you cut the other one, again, the 32 will appear here. That means whatever is the input voltage, that will appear across the diode. So this will be the diode voltage for the second half. And the complete voltage will be this one. In the first half, it will 0, and in the second half, it will be minus 6.29 volt. So this is part 2. And now current ID, again for the first half, this is short circuit, positive makes the diode short circuit. So the current is flowing through here and total voltage will appear across this. So no voltage here, but the current, whatever is the current flowing through this, will be also flowing through this circuit. And the current through this will be this total voltage. We're just considering the peak for the time being. 6.29 divided by 2 will be the peak voltage. I diode peak equal to I resistance peak is equal to Vm over 200 or 2K, 2000 or 2K, and this will give 629 divided by 2000 is 3.145 10 raised to the power minus 3 or 3.145 milliampere. Now this is the peak current, and since the input is following the half sinusoidal, and therefore the diode current will also follow the same pattern. And so this will be the diode current with maximum amplitude 3.45 milliampere. This is for the positive half cycle. Now again, the negative half cycle, we have the negative cycle, no current flowing because of the open circuit. So it will be 0. 0 current, second half cycle like this. And so the total current will look like this: positive half cycle 3.145 milli peak and 0 for the second half or the negative half. Hope you have been able to follow this. Please let me know through your comments. Thank you.